Okay, so now we go to one more of our morning talks. Well, the last one, and this is, I believe this is a very interesting subject here. Let me put this up. So Mo is going to speak for ARM. As far as OAI is concerned, historically, our software has run on x86, but there have been, ARM versions also. Now there is with 5G and with the involvement of ARM in many 5G projects, there are more and more questions that are being asked of the OAI team itself, whether, how much of OAI will work on ARM and what are the different, roadmaps for making it to enabling it on ARM. So that's why I believe that this talk is going to be very interesting. Mo, welcome. Mo is a senior segment marketing manager at the infrastructure line of business at ARM. And he's overseeing go-to-market activities for 5G Open RAN initiatives of ARM. And he's also very actively involved in ORAN and TIP to champion the ARM ecosystem. One of the initiatives there has been Magma, so there's a lot of activity that is ongoing on Magma for ARM. So welcome, Mo. The floor is yours.
Hello, everybody. Thanks, OAR, for having us. So I'll try to stay on my time slot. I assume everybody knows ARM. It's kind of a blue cheese from UK, but if you don't know that, well, yeah, the problem. But one thing that is new about ARM is that everybody is used to having ARM being something that is low power cores for cell phones and IoT devices, etc. A few years ago, ARM started another line of product called ARM Neoverse. These are much more powerful cores designed for infrastructure use cases. There's a few areas of focus. One of them is cloud providers. Now, a lot of public cloud providers have silicons based on these Neoverses, like most famous one is the Graviton line from AWS. There is HPC focus, there is 5G and carrier focus, which we will talk more, and then there is the edge section of that. If you want to look at how the Neoverse in 5G has shown some promise, there are some silicon up there. I won't go into details of this. I assume the slides will be available later. But there has been a few highlights is that, for example, Dish decided to deploy their network on the AWS and using the ARM instances of the AWS, the Graviton 2 silicon. And or recently, HPE announced servers based on Ampere, which can be used for the telco kind of deployments of operator needs like CU/DU deployments or core networks. Recently, Docomo worked with NEC and moved their core network to AWS Graviton 2. Magma is now native on ARM, as Irfan was mentioning, version 1.8 of this. So you can see that because of this section, but anyway, it is there. So what we do here at the ARM is that we not only design the IP, we try to work with everybody across the ecosystem. So we start with designing the IP, but then we work with our silicon partners, whether that's AWS or NXP, Marvell, NVIDIA, and everybody else. Then we go another layer, we work with OEMs, like server manufacturers, and etc. We talk to new network operators and eventually new stakeholders. I mean, you see hyperscalers now are in this world, private 5G stakeholders are in this game. We try to champion the ARM technology across this team, helping them create POCs, give guidance, be the Switzerland in terms of ARM ecosystem. If you break the, can I move this guy again? Yeah, now better. Okay. So if you look at the building blocks, etc., most of our focus, there's two ways to look at this. There is the virtualization movement that is happening now. It's possibly the future of telco. And then there is the embedded side of that, which was what Ericsson's, Nokia's, Samsung's were doing before virtualization came along. If you open up any base stations in the world, there's a 80% chance that it is fully based on ARM. So ARM's value for running heavy loads of telco, 4Gs, 3Gs, and 5Gs is known to people that have been in this industry. Virtualization is something that now is taking up steam, and we believe that for this, with the same argument, we can show value of that. Most of our focus is on the RAN because that's the biggest piece of the CapEx and OpEx for operators. A small intro to Neoverse. Neoverse is a multiple line of products. There is some series like V series. These are really performant cores that are not really, they are just targeting highest possible performance you can get out of a chip. It's targeted at hyperscalers, mostly the cloud industry. Then there is the N series, which is a good balance of power and performance, something that you get something very efficient, but not very power hungry. And E series, which is similar to our ARM legacy mostly, that it is really efficient cores. They are not really powerful, but they are mostly used in places that like not cell phone itself, but similar to cell phone, really battery dependent. Most of what we will champion for 5G infrastructure is on the N series. Because we have a bit shortage of time, I won't go into details. This is some comparison of the ARM cores versus x86 cores from other clients in terms of how much is this, but this is a pure silicon comparison. I have some numbers that shows the 5G performance a bit later too, so I will use my time on that. In terms of the ecosystem, we have been working hard to make our ecosystem as diverse as possible. Of course, there is a big silicon network using the ARM technology. We have been able to work with a lot of OEMs to create servers, COTS servers for the deployments of 5G, various OSs and containerizations. Our latest addition has been OpenShift, which is quite popular in deploying the 5G networks by operators. And it's not limited to this, we keep working with those. When you come to ISVs, we have a lot of names over there focused on private networks, smaller deployments, small cells, up to companies like Mavenir that are targeting more public deployments for operators. And we try to keep our relationships with all the standards of open source projects that are going to have us, technically. I dropped Magma from here, possibly this old, the slide is a bit older. A bit more technical because it is useful to look into the details of this. The RAN section of the 5G, for those that are not familiar, is a few layers of the software that there is a layer 1, layer 2, and layer 3 that creates the different pieces of a RAN network of 5G. Usually 5G RAN network is seen as a disintegrated network, which has a RU, a DU, and a CU. And the most complex part of any 5G or LTE or telco deployment is usually the layer 1 section of this. The virtualization ideas is that we want to run everything on a CPU and go away with custom silicon. It has its own benefits and pitfalls a little bit. One, the biggest pitfall is that when you want to do a layer 1 fully on CPU, some of these loads, mostly there's a piece called forward error correction. It's an encoder decoder for channels redundancy, technically. In LTE, it was called turbo code. In 5G and possibly 6G, it will be LDPC codes. This section is not very CPU friendly, so there are various ways to do this. Some people offload it to an accelerator card or a small section. They just offload this troublesome section to an accelerator, which is called FEC. This is what Intel is doing. with their accelerator cards. And then there is also this school of thought that we will offload this whole layer 1, which is a bit complicated, to some accelerator. This is what, well, we are in Qualcomm building. This is the Qualcomm thinking. And what we have in ARM is solutions for all these kind of deployments. So there is the server side of a 5G deployment, and then there is the accelerator card side. SoC side, well, of course, we have the AWS Graviton2 trees. The Ampere is another company that has built silicons that goes up to 128 cores on ARM. And then Marvell has a chip called Octeon 10, designed mostly for DPU, but it can be used also to run as a server. And then there is the accelerator cards from various companies. These chipsets, I'll come to accelerator cards of that. It took us a while, but we have now a variety of servers that can run 5G loads, or technically there's a variety of OEMs that offer servers for 5G deployments. You see some of them here. And then there is a variety of accelerator cards. No matter if you want to do a look-aside, you can always go with Xilinx, now AMD cards that you can run a layer 1 look-aside solution, which I think OAI layer 1 is one of them. And or you can go with a look-aside solution from these vendors that you see over there. Each one of them has its own expertise markets that they target. And feel free later to approach me here later over email, LinkedIn. We can talk a bit more about the ecosystem. We have also come up recently with a 5G developer workstation. This is this is an Ampere-based solution. It's not every developer for 5G. Imagine you want to do some sort of university lab or a research project on 5G. The server is something really noisy, and it needs its own cooling and etc. We have come up with this developer workstation. It's like a PC, and you can connect the accelerator cards to it, and you can work with our ecosystem to run the layer 1, layer 2, 3 core networks on this. And then you can build something on top of it, or you can run your own, for example, OAI stack on this. It's something useful. We have come up with the our friends at AD-Link and Ampere. You see the spec here. I think they will be shared later again. It is quite useful for making a POC, some sort of research project, etc. Then, because it's the same silicon in the servers, you just move it over there. Nothing changed. It's just another server. Maybe you need some drivers. That's it. Drivers specific to that. Now, I want to get into the advantage of ARM a little bit. As I mentioned, this shows ARM solutions and for deployments of their 5G network. It's an ongoing effort. Also, I mentioned that Docomo moved their core network to AWS. They saw 72% drop in power consumption. So we weren't even involved in this study, but it matched the numbers we saw. What you can always remember is that an ARM core, especially the Neoverse, can be equal to a very strong x86 core. Sometimes, depending on which generation and which generation you compare, but if you compare same generations, usually same performance, but for half the power consumption, 1/3 the power consumption, depending on how your workload is designed. And you can see it here too, that they just moved the NEC core network over there and they got 72%. This is important in 5G deployments because everybody says we are going to consume more and more data. More and more data means more and more compute power. More and more compute power means higher power consumption, higher OpEx for the operators. I don't know, renewable energies, etc. Of course, it's important, but reducing your power footprint is also important. And that's why we believe there is a good reason to try ARM technology in the most power consuming section of the 5G network, which is the RAN part. A little bit of benchmarking we did on 5G. This was done with our with our ecosystem of layer 1, layer 2, 3 companies, accelerators, etc. You will see here we are going to compare the current industry baseline, which is an Intel Ice Lake, with the accelerator ACC100. with two different servers, Ampere server, which already exists in the Martel, and a specific potential server based on the Marvel Octeon 10. This is a 4-node server. Nobody has built it, but we are working with OEMs to see if we can create enough interest to build something and test it for operators. For layer 1 inline, we have chosen one of our ecosystem inline accelerator cards. We have tried this on 3 different loads. It is a bit 5G specific. I won't go into details, but you can see them as a low load cell, a mid load cell, and a massive MIMO cell, which is quite power hungry. So technically, we took a server from each one of what we mentioned, and we saw how many of these loads we can fit into one server, and like a CU-DU combination. These are the numbers. There is the vertical line is the cells you can fit inside a server based on the load, and the bottom line is some sort of performance per watt, something that is really important. It's just we are not only talking about the performance, but how much this costs you. So the horizontal axis is watts per gigabit per second. How many watts do you have to consume to get 1 gigabit per second to your users, to the phones? So left bottom side, there's a mouse here, yeah. You can see this is this baseline. This is a relative chart. So the Intel plus Ice Lake is here. Then we have tried this Ampere plus inline accelerator, something you can go and deploy right away now. And eventually the hypothetical server from Qualcomm Marvel that, from the Quad Marvel, not Qualcomm Marvel, that's an interesting combination actually, but Quad Marvel, that where it can go actually if you really design something telco specific. So you can see, for example, we almost triple the number of the cells even with the Ampere-based solution and make it 6 times more in the same server. That's capacity. But if you look at how much power performance you're gaining, it's almost the same numbers. You are going to consume 3 times less power by just using an ARM server, a generic ARM server. Or if you go for something really dream server, you can get between 4.5 and 5 times saving in your power consumption, which is in line with the numbers that Dish has measured or Docomo has measured publicly. More can be talked about this. This is a quite complicated study. We tried to include everything about a server, NIC cards, crypto encryption, crypto, everything that sometimes ARM ecosystem has advantage, sometimes x86 has, ecosystem has advantage. And we still working. Oh, sorry. Going a bit faster. So we also created something called ARM 5G Solutions Lab. This is a place that our ecosystem comes together and tries to create it's like a playground. You don't have to go find partners. They are already there. You don't have to go procure servers. You remotely connect here and create POCs. It is something that operators come visit. It's quite interesting for them. Usually we call it a pre-tip or any certifying lab. It's an interesting place to shows a solution, then you graduate to a tip solution or an operator solution. Some of the solutions that is happening over there with different partners over there, I have 3 minutes, so I can go into details of that. But there are various solutions from etc. We are trying to bring in a Qualcomm solution. Actually, that's my next meeting after this talk to see if we can bring Qualcomm into the meeting, this lab. There is one final piece. Because OAI has its own layer 1, we just wanted to let you know there is something called ARM RAN acceleration library. This is the vectorized sections of layer 1 that ARM has written specifically for ARM silicon. It can be used to enhance performance of a layer 1 that is being ported to ARM. So I won't go into details, but it has stuff like matrix operations, FFTs, etc. And I think if OAI team is interested to move their layer 1 to ARM, it will be a useful tool. It's open, it's free, not open source, but it doesn't have any strings attached. Finally, this is a sort of call to action. My hope is that we will have OAI on ARM. You can use any of the servers or workload stations over there with some Ampere solution, maybe a telco card from Xilinx to run the OAI, layer 1, layer 2, 3, and the core network running on ARM. I hope we see that, and we are happy to help promote, have it in the solutions lab. So that's what I'm hoping, and some stuff that is legalities, and thank you in your own language.
Thank you, Mo. Any questions for Mo? So,
I have a small question. So thank you for the work.
Sure.
For OpenAirInterface as a developer, rented the platform developer can you go into some details? I mean, for example, now maybe it happens to OpenAirInterface. That was the problem that somebody else is in that platform. So we could get it, how much it costs, and already for it, you can buy it.
You mean the platform, the dev platform, and the servers? So the question is, if somebody wants to use these developer platforms or servers, how much do they cost? We have some funding for different activities. Actually, you might be able to get it from us. I think the developer platform is a few Ks, 3-4K, something like that. Servers are a bit more expensive, maybe 10K. It's the ecosystem. But again, if you have projects in mind, you can reach out to us, and we might be able to find a way to help you getting them, funding them, depends on the project type.
Does it the developer platform does that the radio unit integrated or separate?
No, there is no radio integrated. So technically you will bring your own radio. We are assuming that, for example, you're using one of the accelerator card that has a NIC that connects to the radio unit. So depending on which layer 1 you choose, I think OAI is integrated with some radios, but ARM ecosystem is each layer 1 is integrated with some radios. So technically we can point you in the right direction of getting the pertinent radio there. Yes, technically the layer 1 ecosystem we have, usually it's the ORAN compliant 7.2 split kind of thing. So it's not an ARM thing. ARM is the silicon, the CPU basis, but most of our ecosystem, not most, all of our ecosystem are following the ORAN standards and the tip specs and etc.
Google the return, but might be faster. That the grant is a written library. In one of the last pictures you showed, it won't quite clear me. It runs entirely in R, or it requires some of the acceleration part, like science.
So the silicons they usually have a vector engine. Each CPU has it. So, for example, in Intel terminology that everybody is more familiar is AVX512. ARM has an equal version of that, which is called Neon or SVE. And this RAL is using these vector accelerator. So the idea is not to use any external accelerator. So just the CPUs, the plain CPU and its own vector engine, use the vector engine to expedite these loads. We have even written LDPC and turbo encoder decoders on that, which is good for small throughput, like below 1 gigabit per second, etc. We can get into more details if you want later, but it has a use case. Thank you.
Yeah, thanks for a very interesting talk. As I said, I mean, many in the community now are asking for the ARM ecosystem. One of the things that we want to do with Florian in our lab at Eurocom is to put up a CI framework with on the ARM platforms also to continuously provide an OAI distribution that works with ARM. So yeah, we're looking forward to that.